डियर स्टूडेंट्स, आज हम फिर से इस टॉपिक को डिस्कस करेंगे, हाउ डू मेटल्स एंड नॉन मेटल्स कंबाइन। हमने इसका जो बेसिक कंसेप्ट है, और कल हमने सोडियम क्लोराइड मॉलिक्यूल को भी डिस्कस किया, वो कैसे बनता है, क्योंकि उसमें एक एलिमेंट मेटल है और एक नॉन मेटल है। डियर स्टूडेंट्स, वी हैव लर्न दैट metal plus non-metal, when they combine, they form ionic compound. What happens? Electrons, they are lost by the metal atom, and these lost electrons, they are gained by the non-metal atom with the formation of positively charged metal cation and negatively charged non-metallic ion, and further these ions are held together by electrostatic force of attraction in the form of an ionic compound. Dear students, we also call them as electrovalent compounds. So whenever a metal atom and a non-metal atom, they combine, metal being electropositive, it loses electrons, and non-metal being electronegative, it gains electrons. So the electrons lost by the metal with the formation of a cation are gained by the non-metal, which form anion, and then they are held together by strong forces to form the compound that is the ionic compound or electrovalent compound. Dear students, we have discussed how sodium chloride formation takes place. Na, sodium, being a metal, and chlorine being a non-metal. We have discussed in the previous lecture. Now today we will discuss another example, that is formation of potassium chloride. Formation of potassium chloride, KCl. Dear students, this molecule KCl, it is known as potassium chloride. It contains two atoms. One is the K and another is Cl. Potassium, K refers potassium. So K is the symbol for element potassium, and Cl for chlorine. Dear students, potassium, the atomic number of potassium is 19. So Z is equal to 19. And if we write its electronic configuration, it is in the first K shell we can accommodate 2 electrons. Then next energy level, that is L, we can accommodate 8 electrons, and then in the third we can accommodate 4, and the last remaining has to be placed in the fourth energy level. So dear students, from the electronic configuration, it is evident that this is the last shell of the potassium atom, which we called valence shell or outermost shell. So for potassium to attain this nearest noble gas configuration of argon, nearest noble gas configuration of argon, it has to lose this electron. So what happens if potassium, it loses electrons? K loses its electron in last shell, that is the N shell, and it forms K positive. and it forms K positive. Now its configuration is 2, 8 and 8. This is called as potassium ion. Dear students, you must know that losing one electron is an easy process, and the elements which have only one electron in their outermost shell, they lose it very quickly, very rapidly. That is why such metals are highly reactive, and potassium being one most of the highly reactive metals. So coming to the chlorine, dear students, for chlorine atomic number is 17, electronic configuration is 2, 8 and 7. Dear students, this is the last outermost or valence shell of chlorine. It contains 7 electrons, so it is in short of 1 electron. So the electron that is lost from by the potassium atom is gained by this. 1 electron lost by potassium is gained by chlorine, and it forms Cl negative. So the configuration is now 2, 8 and 8. So these two, K positive and Cl negative, they are held together by electrostatic forces, and they form K positive, Cl negative, and this is the formation of KCl, that is the ionic compound. So uh, we can write here the equation. Suppose it is K, the Lewis symbol or electron dot structure of this K is written like, first we have to write the symbol for the element, that is K, the number of electrons present in its outermost shell, that is 1. So I write here this is the 1 electron, plus it combines with chlorine. So chlorine is having 7 electron in its outermost shell. So I will write here the star so as to distinguish it from the electrons of potassium. So there are 7, 1, 2, 3, 4, 5, 6 and 7. So what happens following this, we have already discussed it. So this electron, this is lost by potassium, or simply we can say that it gets transferred from potassium to chlorine. So with this process, with these changes, K positive is formed and Cl negative is also formed, and these two form a potassium chloride molecule. So this is metal, this is non-metal. So dear students, we have seen how a metal atom chemically combines with a non-metal, and this is the second example in which we have seen the formation of potassium chloride molecule. So dear students, let we discuss third example, and that is formation of magnesium chloride. Magnesium chloride. So magnesium chloride, it is MgCl2. This is the formula. So we can also learn from this example how we can predict or how we can calculate how many atoms of metal reacts with those of the non-metal. What is the ratio of the metal of the what is the ratio of the atoms of the metal or the non-metal? So this can be learned from this example, dear students. So for we have magnesium and we have chlorine. These are the two atoms present in this compound. So magnesium, we have atomic number 12, and for chlorine we have atomic number 17. So just strike the electronic configuration for magnesium, that is 2, 8 and 2, and for chlorine it is 2, 8 and 7. So dear students, magnesium contains 2 electrons in its outermost shell. So what happens? There are actually two processes. It has to either gain 6 electrons to get 288, that is the argon stable configuration, or it has to lose these 2 electrons and it has to form 2 and 8 neon, that is the nearest noble gas configuration. Dear students, this process is not possible, and that is why the magnesium atom, it loses both its 2 electrons present in the outermost or lost shell. So why it has to lose both its 2 electrons, and here potassium loses only one? Dear students, potassium has only one electron. So when it loses its this lost shell electron, it gets the stable noble gas configuration. Here it is compulsory for magnesium to lose both of these electrons to get the nearest noble gas configuration, that's 2,8, corresponding to the neon atom. So what happens here, when magnesium loses both of these electrons, it forms Mg plus 2. Plus 2 indicates that the atom has lost 2 electrons. Plus 1, here potassium, for potassium it indicates that potassium atom has lost its 1 electron. So for every lost electron, we have to add a positive charge for the metal atom. So here 2 electrons are being lost by the magnesium, so we here write plus 2. So the configuration becomes 2 and 8. So dear students, now the magnesium atom has lost its 2 electrons and it has attained the octet. It has got the nearest noble gas configuration. Now it is stable. So coming to the chlorine, dear students, here 2 electrons are available now. So uh, if we look at the chlorine atom has 7 electrons in its outermost shell, so it needs only a single electron, not 2 electrons. So it is important to understand, to remain cautious here. So it needs only 1 electron, so it will need 1 electron, it will gain 1 electron and it will form Cl negative, and the configuration is 2 and 8. So dear students, we have to balance the equation here. What happens? You know that here magnesium gives 2 electrons, but only 1 electron is occupied by chlorine. What is the fate of the other electron? So to make the things balanced, to follow the conservation of energy, momentum, you know that all these processes, so we have to make the number of electrons, or we have to make the equation balanced. So for this we need another chlorine atom. So what happens? These 2 electrons that are being supplied by the magnesium is they are being gained by 2 chlorine atoms, because a single chlorine atom needs only 1 electron. So that is why we have the formula Mg2 plus Cl2 negative. So we have 2 chlorine atoms here and 1 magnesium atom. This is how magnesium chloride formation takes place. So dear students, you can yourself practice many examples of ionic molecules in which atoms are of 2 types, that is the non-metal and the metal, and they combine with the loss and gain of electrons, and these compounds are known as ionic compounds. So dear students, in the next class we will discuss the properties of these ionic compounds, and we will discuss the other mode of combination, that is the combination of atoms where electrons are being shared, where atoms do not lose or gain electrons, they share electrons so as to acquire the nearest noble gas configuration. Dear students, I hope that you have got well this concept. Thanks.